We're on page 17, lesson 19.2. We're talking about transforming quadratic functions. And so normally I don't go too in-depth into the explore sections, but I think it's worth talking about this time because right now, or at least for this part of this credit, we're going to be introduced to something called the vertex form. And I'm not sure if they call it the vertex form, but this formula is kind of like the slope-intercept form in that it tells us what the graph is going to look like. Like the slope-intercept form is a really easy way to graph a line, the equation of a line, and the vertex form is a really easy way to tell us how narrow and how narrow the quadratic function is going to be and where the vertex is going to be. So here are the important parts, and if this is your first time encountering this means nothing to you, but I thought I'd talk about it just a little bit. The a value, that value that comes in front of that parentheses, that tells you the vertical stretch. And if a is greater than 1, you're going to get something skinnier or narrower. And if it's less than 1, but still greater than 0, this one, you're going to get something wider. Right? If it's less than 0, you're going to see it. You're going to see the parabola opening up downwards. So I did mention that actually. If it's greater than 0, the parabola is going to open up upwards, and if it's less than 0, it's going to open up downwards. And then we have the h here in this formula right here. The h tells us the x value of where the vertex is going to be. So depending on whether that h value is negative or positive, it'll tell you whether it's going to be shifted to the left or to the right. And then the k value tells you how far the vertex is going to be shifted up or down on the y-axis. So here we go. So here's an example. Here's a good example that shows us what actually happens. That 2 is greater than 1, so the resulting parabola here is going to be narrower than the traditional f of x equals x squared parabola. This 3 tells us the x value of where the vertex is going to be. That 4 tells us the y value of where the vertex is going to be. Let me draw some arrows just in case you didn't see that. The 3 tells us that, the 4 tells us that right there. Okay, so let's answer some of these questions here. What do you notice about the vertex? This question right here. What do you notice about the vertex of g of x as it relates to f of x? Well, that g of x was translated or moved 3 units to the right and 4 units up. Okay, and then the other question here, what do you notice about the shape of g of x as it relates to f of x? Well, it's narrower. Than f of x. Okay, and so what is the vertex of of g of x? Well, it's what we saw here on the graph right here, that 3 comma 4. What is the axis of symmetry? The axis of symmetry is just going to be that x value there, so x equals 3. Okay, so the next page is just more explanation. I will let you read into that, but here on the next page, on page 19, is where we're going to get some practice and hopefully develop a better understanding of what's going on instead of listening to me just talking your ear off here. But here we have the function right here. G of x equals x squared plus 4. So this looks a little different from what we saw before, right? Before we had this vertex form, a x minus h squared plus k. And so in this case right here, we don't see a parentheses. We don't see an a. We do see what seems to be a k. And that's the point of this first problem. All we're doing is we're learning what the k value does. And so let's not think about the a or the h yet. Let's just think about the k, which is this 4. And so if we make a table of values in step 1, x squared plus 4 And if we fill this out, we're going to plug these x values and these domain values into the function and see what we get. If we plug it into this function here, negative 2 squared is 4. 4 plus 4 is 8. And then we're going to do the same thing for all of these. Negative 1 squared is 1. 1 plus 4 is 5. Plug this one in. 0 squared is 0. Plus 4 is 4. And then, like we learned before, these are symmetrical, so we can just go ahead and fill these in, 5 and 8, because this is our axis of symmetry here. So let's plot the points. Negative 2 comma 8 is right here. Negative 1 comma 5 is right here. 0 comma 4 is right there, and then again symmetrical. So we have a graph that kind of looks something like that. Okay, and so if we continue on with this, the y-coordinate, let's look at step 3. The y-coordinate for the minimum value right here, the minimum value is 4, and this occurs when g of 0, when the x value is 0, when g of 0 equals 4. Determine the axis of symmetry from the graph. Well, like we said, it's just the x value, and the axis of symmetry is here just at x equals 0. And describe the transformations. Well, the parent function has been translated 4 units up. Right? It hasn't gone left or right. And again, we can tell just by looking at that k value up there. 4 units up, because it was positive 4. Okay, so let's take a guess at what question 2 is going to be. We can see that the k value here is negative 7. Do you think, so just take a wild guess, is it going to go up or down, right? Before it was positive 4 and went up 4 units. What do you think negative 7 is going to do? Well, hopefully you've gotten to the conclusion that, or the hypothesis that with this one you're going to go down 7 units, and certainly let's take a look at what's going to happen. We're going to fill in these this table again for step 1, and let's just continue using the same domain values here, negative 2, negative 1, 0, 1, and 2, and then plug these in. So plug these in here. Negative 2 squared is 4. 4 minus 7 is negative 3. 1 squared is 1, or sorry, negative 1 squared is 1. 1 minus 7 is negative 6. 0 squared is 0. Minus 7 is negative 7. And then, again, these are symmetrical, so I'm just going to go ahead and do that. Okay, so let's see here. Negative 2 comma negative 3 is right here. Negative 1 comma negative 6 is right there. 0 comma negative 7 is right there. And again, symmetrical, so we're going to do those. What we don't see are actually the x-intercepts, where it crosses the x-intercepts. I imagine if we were to extend this a little bit, let me see, negative 3. Well, not necessarily an x-intercept, right? At negative 3, that's 9 minus 7, which is 2. So the x-intercept is going to be somewhere in between 3 and 2, it looks like, because by that point it's right here. I was hoping it'd be a clean integer, but it's not. So, and that is not a nice curve, but that's what you get, right? Hopefully your curve looks better than mine. Step 3, determine the minimum output value. Okay, so there's a minimum output value at negative 7, and that happens when x is 0. Determine the axis of symmetry. So we haven't moved left or right, so the axis of symmetry is x equals 0. And so this transformation can be described as this parent function has been translated 7 units down. Okay. All right, so that was what happens when you have a k value right there. The next page, again, is more explanation. Go ahead and read that. Pause the video if you must. And on page 21, we're going to continue on with a different one. This time, we don't have a k value, right? Let me actually rewrite the function again. G of x equals ax minus h squared plus k. And in this case, again, we don't have a k value, right? We don't even have a, well, we do technically have an a value of 1. We just don't write it. But now we have an h value. Okay, so let's see what happens for the h value. So we're going to plug these in. So again, we're going to plug it in there for x, the domain values. So negative 2 minus 2 is negative 4. Negative 4 squared is 16. Plugging in negative 1, we get negative 1 minus 2 is negative 3. Negative 3 squared is 9. Plugging in 0, 0 minus 2 is negative 2. Negative 2 squared is 4. And then plugging in 1, 1 minus 2 is negative 1. Negative 1 squared is just 1. And then plugging in 2, 2 minus 2 is 0. 0 squared is just 0. 3 minus 2 is 1. 1 squared is 1. And then plugging in 4. 4 minus 2 is 2. 2 squared is 4. So I hope you can see that right here, this is our this is our axis of symmetry right here, right? And it's becoming symmetrical from there on out. Okay, so let's plot these points. Negative 2, comma 16 is right here. Negative 1, comma 9 is, we're gonna have to kind of ballpark this right above the 8. 0, comma 4 is right there. 1, comma 1, somewhere about right there. Okay, and then 2, comma 0 is right here. 3, comma 1 is right there. 4, comma 4 is right here. And so the idea is, even though it's not perfect, it's going to do something kind of like that. Again, not a perfect parabola, but you get the picture. So let's take a look at step 3. The minimum value right here is 0. So when that happens, not when g of 0, right? G of 0 would be 4. We don't want that. It happens when x equals 2. So when the g of 2 equals 0. And we can see that right here, if you haven't noticed, right there. Axis of symmetry is x equals 2, right? This is right here. This is our axis of symmetry right here, when x is 2. And so to describe the transformation, the parent function has been translated 2 units to the right. Okay, because normally it would be at x equals 0. Now it's at x equals 2, so it's shifted over 2 units. Now, here's one thing I want to draw your attention to. 2 units to the right, but look, it's x minus 2. So please don't get that confused. The number one mistake I see people making is they'll see that negative 2 and assume that you move it 2 to the left, which is not the case, right? The shortcut that I hope you catch on to is that the original formula says x minus h, so whatever the h value is. So if that h value was negative, then it would turn that expression inside the parentheses into x plus h. So you'll get that with practice. Okay, so here we have a situation where, here, this is x plus 3. Right, before it was x minus 2, and it shifted over 2 to the right. Well, when it says x plus 3, do you think it's still going to shift over to the right? Actually, it isn't, right? It's going to shift over to the left. I know it's kind of backwards, but you'll get the picture. And hopefully, when you graph, or when you create a table for these, it'll make more sense. Okay, so going with our hypothesis of that it's going to shift 3 over to the left, I'm going to actually put negative 3 here. And let's pick some values around the negative 3 instead. Negative 4, negative 5, negative 6, negative 2, negative 1, and 0. Okay, so let's plug that in. It's negative 6. Plug it in there. Negative 6 plus 3 is negative 3. Negative 3 squared is negative 3 squared is 9. And then plug this in. Negative 5 plus 3 is negative 2. Negative 2 squared is 4. Negative 4 plus 3 is negative 1. Negative 1 squared is 1. And then negative 3 plus 3 is 0. 0 squared is 0. And then again, it's symmetrical. There we go. My plan is working out here. So negative 6 comma 9 is going to be right about here. Negative 5 comma 4 is right there. Negative 4 comma 1 is right here. Negative 3 comma 0. There we go. There we go. And 0 comma 9 is going to be right there. So we have our parabola kind of right there. Again, I apologize for my shaky hand, but you get the picture. Minimum value, again, is right there when is 0, when g is, looks like, what is that, negative 3? g of negative 3 is 0. Axis of symmetry is when x equals negative 3. And the parent function has been translated 3 units to the left. Okay, and again, I draw your attention to this. It's going left, even though it says plus 3 here, just because of how the equation works. When it's positive, you're going to shift over 3 to the left. What I mean by positive is when it says x plus something, it's going to shift over to the left. When it says x minus something, it's going to shift over to the right. Okay, so more of the same. You can read that next explain section on your own. Here, we're going to combine everything that we know. Right, now we have a k value, and now we have a h value. And again, let me rewrite the vertex formula here. X minus h squared plus k. So here in this case, again, we have an h, now we have a k. So let's identify the vertex. So now we have the k. That's easy to tell, right? That's negative 1. Here, remember, when we have a plus something, we need to actually remember it's going to shift over to the left. So in this case, it's going to be negative 3, not positive 3. It's going to be negative 3. So the axis of symmetry is just that value there when x is negative 3. Let's see step 3. Determine whether the graph opens upwards or downwards. It's positive. Therefore, it's going to open up. So x opens upwards. And let's make a table of values centered around the vertex. So the vertex meaning negative 3. So I'm going to put that in the center. Negative 4, negative 5, negative 6, negative 2, negative 1, 0. Much like the previous problem that we did. And let's kind of fill these in. So, this is going to be complicated. Go ahead and feel free to use Desmos if you want to. But just you're going to have to kind of trust me on the mental math that I'm going to be doing here. Negative 6 plus 3 is negative 3. Negative 3 squared is 9. 9 times 2 is 18. 18 minus 1 is 17. Negative 5 is going to be 7. 1. Negative 1. 1, 7, and 17. And this isn't because I'm a genius. I'm just looking at the answer key here. But you might want to double check my work by going on Desmos and filling out that table, seeing what happens. Negative 6, let's go and graph this. Negative 6, 17 is off the graph, so we're not going to be able to do this one. Negative 5, 7 is right here. Negative 4, comma 1 is right here. Negative 3, comma negative 1 is right here. Negative 2, 1 is right here. Negative 1, comma 7 is right here. So we have this long skinny parabola here. Right? Describe the transformations. So let's see, it's narrower. The graph, so let's say it completely in complete sense. G of x is narrower and shifted or translated 3 units left and 1 unit down. Boom. Okay. Question 2. Okay, this one's interesting, right? Let's see the vertex. Vertex is going to be 4, or the k value that is 4. And look at this, it's in the proper form, so this one's just going to be positive 2. The axis of symmetry is just this x value when x equals 2. Step 3, let's see, since a equals negative 1, look at this, negative 1. And it's negative, so the graph opens downwards. And then let's make a table of values based on the axis of symmetry 2. So let's see. Let's do 1, 0, negative 1, 3, 4, 5. Okay, so when we plug in negative 1 into the function here, so again, we're plugging this into here. Negative 1 minus 2 is negative 3. Negative 3 squared is 9. And that becomes negative 9 plus 4 becomes negative 5. Let's see, 0 minus 2 is negative 2. Negative 2 squared is 4. That becomes negative 4 plus 4 equals 0. And again, here I go with the semi-cheating, but I'm the teacher here, not, so neener. So let's go and graph this. Negative 1 comma negative 5, 0, 0. 1 comma 3, 2 comma 4, 4 comma 0, or sorry, 3 comma 3, 4 comma 0, 5 comma negative 5. Right, so we get this graph that opens up downwards. Okay, so let's describe the transformation. Well, the graph of g of x opens downward and is translated 2 units right and 4 units up.